Hello everyone, welcome to the next session of fluid mechanics. In this session, we are discussing numericals on the topic of viscosity. If the velocity distribution over a plate is given by u is 2 by 3y minus y square, the velocity profile is given in which u is the velocity in meter per second at a distance y meter above the plate. Determine the shear stress at y is 0 and y is 0.15. So I need to find tau at y is 0 and tau at y is 0.15 meter. Take dynamic viscosity of fluid as 8.63 poise. Now we know the conversion. 1 poise is 1 by 10 Newton second per meter square. So this will be 0.863. For solving, I will start with this equation u that is given. Let's write down in rough the formula of tau, that is mu du by dy. So if I have to find tau at a particular point, I need to know du by dy at that point where I am calculating tau. So I need to find du by dy and I don't need this equation of u. So what I'll do is I'll differentiate this equation. With respect to y. Therefore, I'll get du by dy will be 2 by 3. Since this is y, the derivative is 1 and the derivative of y square is 2y. Now I need to calculate du by dy at y is 0 and at y is 0.15. So let's calculate that. Du by dy at y is equal to 0. I'll substitute y is 0, so this becomes 2 by 3. And I'll calculate du by dy at y is 0.15 meter. So this becomes 2 by 3. So this becomes 0.367. Now let's substitute in the equation of tau, that is mu du by dy. So when I calculate tau at y is 0, this will be mu, that is 0.863 into du by dy at y is 0. So therefore tau at y is 0 will be 0.863 into 2 by 3. I get this value as 0.5756 Newton per meter square. Next, I need to calculate tau at y is 0.15. This will be mu into du by dy at y is 0.15. So this makes it to 0.863 into 0.367. When I multiply these two, I get 0.3167 Newton per meter square. This is the value of y at 0.15. This is how we will solve this numerical. Let's take up the next one. A plate 0.025 mm distant from a fixed plate. So I have a fixed plate, and from this plate there is another plate at a distance of 0.025 mm. So this is the value of dy, distance between two plates. I'll convert this into meter. 0.025 into 10 raised to minus 3 meter. Moves at 60 centimeters per second. So this plate is being pulled with some velocity u. So I'll write this value as u2 because at this point the velocity is 0, u1. So let me say that this velocity is 60 centimeters per second I'll convert this into meters per second by dividing with 100. So this becomes 0.6 meters per second and requires a force of 2 Newton per unit area, that is 2 Newton per meter square. This will be tau, 2 Newton per meter square, to maintain the speed. Determine the fluid viscosity between the plates. So here obviously there is some fluid in between. I need to calculate the value of mu. I can say tau is mu du by dy. Tau value is given as 2. Mu I need to calculate. Du will be u2 minus u1, final minus initial, and this dy is also known, 0.025 into 10 raised to minus 3. u2 is 0.6, u1 is 0. On substitution, I'll get the value of mu as 8.33 into 10 raised to minus 5 Newton second per meter square. Let's take another one. A flat plate of area 1.5 to 10 raised to 6 mm square. So the value of A is given. Let's convert this into meter square. We know 1 meter is 10 raised to 3 mm. So 1 meter square is 10 raised to 6 mm square. So 1 mm square will be 10 raised to minus 6 meter square. So these two get cancelled out and what remains is 1.5 meter square. Is pulled with a speed of 0.4 meters per second. So U is given as 0.4 meters per second relative to another plate located at a distance of 0.145 mm. So again, like the previous numerical, dy is given. This is U2. Find the force and power required to maintain this speed. To find force F and power P, if the fluid separating them is having viscosity as 1 poise, the value of mu is given as 1 poise. I'll convert this into Newton second per meter square by dividing with 10. For solving this, I'll use the formula tau is mu du by dy by Newton's law of viscosity. We know that shear stress is force upon area. Now when I substitute, force is unknown, area is 1.5, mu is given as 0.1, du will be u2 minus u1. u1 is 0 because there is a fixed plate and there is another plate here which is being pulled by the velocity u2. This is distance dy. So when I substitute here, I will get the value of F. u2 is known, u1 is known, dy is known. I obtain this value as 400 Newton. Now next I need to calculate power. We know very well the unit of power is watt. Watt is joules per second and joule is Newton meter. So this is how we can study the unit. When we study the unit, we will come to know that for power, I can use a very simple formula. Force for Newton and meters per second is nothing but velocity. So when I multiply 400 into 0.4, what I am obtaining, 160 watt, is the power required for pulling this plate. Let's take another one. Determine the viscosity of a liquid having kinematic viscosity 6 Stokes. So new value is given as 6 Stokes. I can convert this into meter square per second. We know Stokes is centimeter square per second and 1 meter square per second was 10 raised to 4 centimeter square per second. So this will be 6 into 10 raised to minus 4 meter square per second. And specific gravity S is given as 1.9. I need to find viscosity, that is dynamic viscosity mu. We know nu is equal to mu upon rho. The value of nu is already known. I need to calculate rho. When S is given, it is very simple to calculate the rho value. So 1.9 is rho upon rho of 1000. Therefore, rho is 1900 kg per meter cube. When I substitute this in this equation, I have therefore 6 into 10 raised to minus 4 is mu upon 1900. When I cross multiply, I get mu as 1.14 Newton second per meter square. Let's take up one last numerical. If the velocity profile of a fluid over a plate is parabolic with the vertex 20 centimeter from the plate. So this is your plate. From here your topmost surface is given at 20 centimeter maximum height. Where the velocity is 120 centimeters per second. So this is my velocity profile which is parabolic. At this height, the velocity u is 120 centimeters per second, which will make it to 1.2 meters per second. Calculate the velocity gradients and shear stresses at a distance of 0, 10 and 20 centimeter from the plate. At y is 0.2 meter, my value of u is 1.2 meters per second. Also, the viscosity of the fluid is given. Mu is 8.5 poise, which will be 0.85 Newton second per meter square. I have to find the value of tau at y is 0, tau at y is 10 centimeter and tau at y is 20 centimeter. I also need to find du by dy, velocity gradient at y is 0, du by dy at y is 10 centimeter and du by dy at y is 20 centimeter. Now for this numerical, the equation for u, velocity profile, is not given. So let me assume, let u is ay square plus by plus c. I am assuming a relation between u and y of second degree because the equation states the nature of the curve of velocity profile. Since it is parabolic given here, so obviously I will have to assume an equation of second degree. Had it been linear, I would have taken a linear equation with degree 1. But here I have to take 2 because it is parabolic. So this is my first equation that I assume. Now I need to calculate the value of a, b, c, which are constants. For that I will assume some boundary conditions. So let's start with boundary conditions. We know at y is 0, that is on the fixed end, my velocity will be 0. So I can substitute the first one here. Therefore, 0 is equal to 0 plus c. Everything becomes 0. So the value of c directly comes down to 0. So I can say u is now ay square plus by. First constant c has been found. Next, I can use the boundary condition that is given to me. At y is 0.2 meter, u is 1.2 meters per second. So let's use that. At y 0.2 meter, u is 1.2 meters per second. So I'll substitute in equation 2, which is u is equal to ay square plus by. So I'll get u is 1.2, a into 0.2 square plus b into 0.2. So this will be 1.2 is 0.04a plus 0.2b. Let me mark this as equation 3. The third boundary condition that I am going to use is at y is 0.2 meter. If I take derivative of this term, I get du by dy. Since it is a constant value 1.2, its derivative will be 0. So let's take up this equation 2 and find its derivative. This will be du by dy is equal to 2ay plus b. This is from equation 2. I am differentiating equation 2. So when I substitute, therefore 0 is equal to 2 into a into 0.2 plus b. So this becomes 0 is equal to 0.4a plus b. Let's take this as equation 4. On solving 3 and 4 simultaneously, I will get the value of a and b. I get a as minus 30 and b as 12. Now I will substitute these two values in equation 2. Substituting a and b in equation 2. Now since I know this equation, now it becomes very easy for me to calculate du by dy. This will be minus 60y plus 12. When I calculate du by dy at y is 0, it is 12. Now if you look at this, we have already discussed the unit is per second. When I substitute du by dy for y is 10 centimeter, which is 0.1 meter, this will be minus 6 plus 12, that is 6 per second, and I'll calculate du by dy at y is 20 centimeter, that is 0.2 meter. This will be minus 12 plus 12, that is 0. So I have found these three values. Next I need to find tau at y is 0, which will be mu into du by dy at y is 0. Value of mu is 0.85 into 12. This is 10.2 Newton per meter square. Next I'll calculate tau at y is 10 centimeter, which is mu into du by dy, where y is 10 centimeter. This becomes 0.85 into 6, that is 5.1 Newton per meter square. Last I'll calculate tau at y is 20 centimeter, which is mu into du by dy at y is 20 centimeter. So this becomes 0.85 into 0, that is 0. So this was the last numerical on this topic of viscosity. I hope you have understood all the numericals. If you have any doubt, please write to me in the comment section. See you in the next session. Thank you.